Hello everyone, my name is Victor Sanchez and this is my final research presentation. Its title is The Effects of a High-Fat Diet on Anaerobic Exercise Performance in CrossFit Athletes. Let's go to the next slide here. So for my introduction, a few things we got to get out of the way first, just some basic physiology, biophysiology. We won't go too in depth because it can get pretty extensive, but anaerobic basically means without air or without oxygen. And anaerobic metabolism becomes the main metabolic pathway of energy to our working muscles when exercise, and our exercise when our heart rate increases to an 85% of our maximum. So what that means is about when we're doing, pretty strenuous, high intensity exercise. Maybe some people are familiar with CrossFit type workouts or like HIIT, those type of high intensity workouts. Usually, this type of metabolism to our muscles is what's fueling us at the time. And so it usually peaks about 90 seconds and lasts anywhere from about 30 seconds to 2 minutes is optimal for this type of metabolism. Um, it's much less effective and can only utilize glucose and glycogen. So if we look over to the model here on the right, we kind of have a little flow chart of aerobic glycolysis versus the anaerobic glycolysis. So obviously we have aerobic glycolysis amongst other types of metabolic pathways our bodies can utilize to produce energy when we're consuming oxygen. So this just basically turns glycogen into glucose. We get a little bit of energy out. That turns into pyruvic acid with sufficient oxygen. That turns into more energy, and we kind of blow off the water we retain, and we blow off the CO2 in our breath. So looking over to the anaerobic glycolysis, we have the same starting products of the glycogen to glucose, and then we get the pyruvic acid as well. But now with insufficient oxygen, our body's not able to take enough oxygen, so we're not able to blow off that CO2 and water. So it breaks it down into lactic acid. And so excessive amount of lactic acid in the skeletal muscle is what slows down the contractions. It causes fatigue and it prevents individuals from maintaining peak performance. So this is why when we're doing those high intensity type workouts, we tire out more quickly and are unable to sustain that high performance for a very long time. So based on what is known about the biomechanical processes of how individuals are able to create energy during these high-intensity bouts of anaerobic exercise, there's been speculation whether consuming a high-fat or a high-carbohydrate diet would be better for an athlete's performance. So I made a little flowchart here, which kind of is interesting. So assuming that we had a high-fat diet or something that's kind of popular now is similar to the ketogenic diet would be the same thing. So what our body does when we consume a high amount of fat and we starve it of carbohydrates is our body switches over in metabolisms to utilizing triglycerides and using fat as fuel. So it starts out as triglycerides, which is basically fat. It's broken down in our body to fatty acids, which is taken into liver, and that liver produces ketone bodies. So liver also breaks it down further and turns into acetyl coenzyme A. So acetyl coenzyme A can then enter the citric acid cycle, which is one of the main metabolic producing pathways for our body, and that gives us energy. So if our body uses triglycerides to basically get to acetyl coenzyme A, well, our body can only utilize anaerobic glycolysis in these types of high intensity bout workouts. And acetyl coenzyme A cannot enter anaerobic glycolysis. So if our body is breaking down acetyl coenzyme A to give us energy, and we're not able to enter that into anaerobic glycolysis, then we're not able to produce any energy. So this kind of begs the question, if acetyl coenzyme A is unable to enter the anaerobic glycolysis, then how can anaerobic exercise be sustained or performed on a high-fat diet? So here's my research question. It is, will a 90-day protocol of consuming a high-fat, low-carbohydrate diet affect anaerobic exercise performance in CrossFit athletes? I chose the 90-day protocol because it was short, relatively short, and from all the research I studied, it said at least a 6-week protocol of consuming a high-fat, low-carbohydrate diet was about the average, the minimum average for switching metabolic pathways in the body to utilizing fat for fuel. My hypothesis is that participants consuming the high-fat diet will exhibit a decline in anaerobic exercise performance. So here was the methods for my research experiment that I was conducting. So I started with 10 CrossFit athletes, 5 males and 5 females, ages 20 to 30, that had a minimum of 1 year experience training in CrossFit, and they would undergo an initial testing. So without whatever their baseline standard was of nutrition and training, they would come in, basically perform the test. And then they would consume the 90-day protocol of the high fat, which is about 75% of their caloric intake, and a low carbohydrate, less than 5% of their caloric intake for 90 days, and then come back and redo the same exact testing. And that was how we were going to measure the change in difference in results. The athletes were to continue their regular training regimen between testing procedures. And the statistical analysis we're going to use is the paired t-test. The paired t-test is used to explain the difference in means and how reliable or valid the test results were, and especially useful in this in comparing an initial and a post in difference, and looking at the results there. So here was the anaerobic testing battery for the athletes we put the participants through. The first one's going to be the Wingate anaerobic test. This is kind of the standard that was established to measure anaerobic capacity and lactate threshold in athletes developed about the 1970s, I believe. So what it is a 90-second bout on a cyclogometer, and what the athletes do is they're going to go full effort, maximum effort for 90 seconds as fast as they can go. And you can see here it's hooked up to a computer. So what that computer is doing is measuring the actual meters that the participant's cycling, and then it takes the meters cycled and actually converts that using an equation to give a peak power output, or an anaerobic capacity. So that was going to be our first test in the testing protocol. Our second test was going to be a 400-meter sprint, which usually peaks out about 2 minutes, so it's kind of perfect in that anaerobic window. So the athletes are going to perform a maximum effort 400-meter sprint, and then be measured in seconds. And then the final and third test was going to be a 1-rep maximum back squat. So the athlete would give the athlete significant time, maybe I think it was 5 to 6 minutes to warm up, heavy, light, whatever they do, stretch. And then they would have 5 attempts to establish a 1-rep max back squat that's measured in kilograms. So for our discussion, after looking at the results from the study conclusively demonstrated that consuming a high-fat diet significantly negatively affected anaerobic performance amongst the participants. These findings were consistent with other research studies that test anaerobic exercise performance in individuals who consumed a high-fat diet for various durations of time. So I included some of the results here. So in the Wingate average test, participants on average were reduced by about 6 meters, and the same in peak power output measures in work. So their anaerobic capacity decreased, as well as the amount of meters they were able to cycle in the 90 seconds. For the 400-meter sprint, the average increase was about 15 seconds at 14.8. So participants on average increased their time, so ran slower by 15 seconds. And then in the 1-rep max back squat, we also saw a decrease in load successfully being able to be completed. And that's about negative 4.4 kilograms on average, about 9 to 10 pounds. In closing here, so some of the limitations of the research experiment that I conducted. I think the first two kind of go together with equipment and simplistic design. Obviously, like I said, there's really in-depth biological markers that can be tested for, lactate threshold, and precursor enzymes that go into how the body produces energy. So not having those advanced testing readily available to measure blood tests and measure specific enzymes and those sorts of things kind of makes it limits the validity of the experiment with being very simplistic in design. Another thing was the duration of protocol. A lot of the research out there on this type of high-fat or ketogenic diet on anaerobic performance is fairly new topic to the realm of fitness and nutrition, and so there hasn't been any long-term studies. So there's been a few 90-day, 8-week protocols out there that have tested this and kind of seen the differences, but there hasn't been anything over a year. It's kind of something that was missing in my research that I would have liked to follow up on, or like to have seen, was studies of following athletes over long term for a year or years for that matter. And then also without taking considerations for changes in body composition. So, assuming the athletes achieve acidic ketosis and were on this high-fat diet, they would expect to lose, body weight, possibly body weight, body mass, and decrease the body fat percentage. So that could definitely affect their ability to perform at a peak level as well. I mean, with losing weight, they may not be able to lift the same amount of weight in the back squat. So taking into account for that, with a decreased body composition might have changed the results a little bit. So I think more research is needed to determine whether our bodies are able to adapt to a high-fat, low-carbohydrate diet over an extended period of time and produce more efficient metabolic pathways to fuel our bodies during these high-stress bouts of vigorous exercise. So the one thing like I said, without long-term research, we don't know how our body can possibly adapt. We know that we have evolution and our body's way to adapt to different types of stimulus is amazing. So without having that long-term research to study to conclusively say, we really don't know if 90 days was too short or too long, or what kind of physiological adaptations could have occurred with the longer duration of time. I think this is important because nutrition is the fundamental foundation of fitness, and finding that perfect formula for determining the number of macro and micronutrients will always be a question that researchers seek to answer, because everyone's always looking for an edge, or always looking to better their performance, and looking for something to improve upon. So I think nutrition is a key kind of opening to the possibilities of unlocking more potential for the human body. So that was my research project. Thank you guys for watching. I hope you guys had a great semester, and God bless.